Chapter 5 is about properties and attributes of triangles. In Section 1, we're going to talk about perpendicular and angle bisectors. So by the end of this lesson, you should be able to prove and apply theorems about perpendicular bisectors and about angle bisectors. So let's remember what those things are. Perpendicular bisector, even if you don't know what it is, you should be able to figure it out by the term. Perpendicular means that it's going to meet at a 90-degree angle. Bisector, remember, means something that cuts it in half. So a perpendicular bisector is a line that's going to cut a segment in half. So this segment AC gets cut by DE, meets at a 90-degree angle, and A to B is exactly the same as B to C. So how is that useful? Well, we have two theorems. We have the actual theorem and then we have the converse of the theorem. Both are equally important, but they prove different things. The regular perpendicular bisector theorem says that if a point is on a perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So here the things that we're given are that XY and AB are perpendicular, and that because it's a perpendicular bisector, we end up with this being congruent to this. So now if there's a point up here, any point here, then it's equidistant from the endpoints of the segment, meaning that XA is congruent to XB. And the converse is the other way around. It says if you have a point, so if we have this point and we know that those two lengths are the same, then we can prove two things. We can prove that this is perpendicular and that AY and YB have to be congruent. So using those two things, let's do a couple problems. First one says find the measure of MN. So right now they're giving us that this NP is perpendicular to ML, and they're giving us that MP is congruent to PL. So this right here tells me that NP is a perpendicular bisector. And because of that, the thing that we know is that this side has to be congruent to this side over here. So if NL is 2.6, it has to be congruent to NM, and this also has to be 2.6. And this is by the perpendicular bisector theorem. So we're kind of doing a little proof without actually doing one. So find the measure of BC. We got to find this whole thing right here. So take a look at the information we're given. I know that this side is congruent to this side, and this is perpendicular right here. So because BA is congruent to CA, and the AD is perpendicular to BC, then we know that BD, so this right here, has to be congruent to DC by the converse of the perpendicular bisector theorem. So because of that, BD also has to be 12. And then, because we're trying to find BC, this whole length right here, all we got to do is take 12 plus 12 to give us 24. Let's try one more. Find the measure of TU. So they're giving us that this is perpendicular. UW is perpendicular to TV. And we know that TW is congruent to WV. So because of that, we can use the perpendicular bisector theorem to say that TU has to be congruent to UV. So I know 3x plus 9 has to be the same as 7x minus 17. But now we can solve this for x. So let's do a little algebra. I'll add 17 to both sides. So we get 26 equals 4x. Divide both sides by 4. This won't come out nice and pretty, but that's okay. We'll get x goes into this 6 times evenly with 2 left over, so 2/4 is the same thing as 1/2. So we get 6.5 for x. And then because we're trying to find tu, we got to plug that in. So if we do 3 times 6.5 and then add 9, 3 times 6.5 will give us 18 plus another 1.5, so 19.5. Plus 9 will give us 28.5. So a little bit of algebra mixed in there with our geometry. So the next thing we got to talk about is angle bisectors. In this case, BD bisected angle ABC. And remember what that means is you end up with 2 equal angles here. Now the other thing we have to remember is the shortest distance from a point to a line. Remember we said the shortest distance from any point to another line is perpendicular. So if we have this point D right here, and I want to find its distance from AB, I'm going to draw a line that's perpendicular. So point D to AB is shortest at ED. And remember that's because ED is perpendicular to AB. So that was one of the theorems we learned a while ago, and now we're actually going to use it. So you need to remember those 2 things in order for these 2 theorems to make sense. The angle bisector theorem says that if a point is on the bisector of an angle, so you have this angle and it's being bisected, and I have some point, this random point C here, then it is equidistant from the sides of the angle. So if I find the shortest line here, these have to be congruent. AC to CB have to be congruent. And then the converse says, if you have a point and these 2 things are congruent, then you know that this ray right here bisected those angles, and those angles have to be congruent. So again, both equally as important. They just give you different things, and then you can prove different things from it. So let's do an example. Find the measure of EFH, so here to here to here, given that EFG is 50 degrees. So EFG, all of this is 50 degrees. So now the interesting information here is that we know those 2 things are the same distance. So by the converse of the angle bisector theorem, angle EFH has to be congruent to angle GFH. And because those add up to 50, each of them have to be half of that, or 25 degrees. So that means EFH has to equal 25 degrees. Let's do another one. Find the measure of MKL. So we're looking for this angle right here. So again, because we know that these are congruent and these are perpendicular, these angles have to be equal. This has to be, KM has to be your bisector. So because of that, I know that 3A plus 20 has to be exactly the same value as 2A plus 26. So if we solve this, subtract 20, we get the A is 6, and then all we got to do is plug it back in. 2 times 6 plus 26. 12 plus 26 will give us 28 degrees. So last type of problem, and this one's a little more difficult, has lots of work with it. So we need to write an equation in point slope form. Remember that's y minus y1 equals m times x minus x1 for the perpendicular bisector of a segment with endpoints at 6, -5 and 10, 1. So the first thing we're going to do is actually graph those on here. So go over 6, down 5, and then over 10, up 1. So here's this segment. Usually this segment is out in space, but this time it's actually on a coordinate plane. So the perpendicular bisector means two things. It has to hit at a 90-degree angle, and it also has to cut this in half. So the first thing we can do, and it doesn't really matter the order, is let's find the halfway point. And remember, we call this the midpoint. So back in chapter 1, we learned the midpoint formula. And remember, it was just basically the average of our points. Take your x's, you add them up, you divide by 2. You take your y's, add them up, and you divide by 2. So let's plug that in. So my x's are 6 and 10. And my y's are -5 and 1. So I get 16 over 2 for x, and I get -4 over 2 for y, or 8, -2. Now this point is right in the middle, over 8, down 2. Hopefully it looks like that on your graph. This is the bisector part. So we have found what's right in the middle of here. Now the next thing we have to do is figure out what direction a line would go in if we want it to be perpendicular. So we need some type of line through here that crosses at exactly a 90-degree angle. And instead of just guessing and checking, what we're going to do is apply our knowledge of slope on the coordinate plane. So this is why we did the stuff that we did in chapter 3. So this whole perpendicular thing. Remember, lines that are perpendicular have opposite reciprocal slopes. So let's find the slope of this green line that we have here. And remember, slope is y2 minus y1 over x2 minus x1. So if we plug our stuff in, we subtracted a -5, so we're really adding. So we end up with 6 over 4, which reduces to 3/2. You can also count. If you go up 3 over 2, up 3 over 2, you end up with 3/2. So now this is the slope of the green line. Remember that the perpendicular slope would be the opposite reciprocal. So you flip it over 2/3 and you change the sign. So this slope right here is the slope of the line that we need. And we also know that it has to go through this point because it has to cross right in the middle there. So now what we're going to use is this point slope form and plug in what we just found. So our answer is going to be y minus the y in our point, which is -2, has to equal the slope, which is -2/3, times x minus the x in our point, which is 8. Now we could simplify this, put it in y equals mx plus b, but it just asks us to find an endpoint slope form, so we can leave it just like that. We'll do lots of practice with this stuff in class. So finally at the end, you should be able to prove and apply theorems about perpendicular bisectors and angle bisectors. Make sure you write down any questions you have, and we can go over them in class. Have a good night.